Today we will discuss about alkaloids. Prior going for alkaloid containing crude drugs, let us see what is meant to be an alkaloid. These are organic products from natural or synthetic origin which is basic in nature, contains one or more nitrogen, normally heterocyclic nature, possesses specific physiological action on human or animal body in lower dose. Alkaloids are generally classified into true alkaloid, pseudo-alkaloid and proto-alkaloid. True alkaloid are generally goes with definition. Proto-alkaloid contains nitrogen as heteroatom in side chain of heterocyclic ring. For example, ephedrine. If you see ephedrine here, whatever the nitrogen heteroatom is present in the side chain, whereas caffeine is a pseudo-alkaloid even though it is having nitrogen in the basic moiety as an heteroatom, but it is not derived from amino acid and it doesn't respond to the alkaloidal reagents. Properties. Most of the alkaloids are colorless, crystalline, but some of the compounds are amorphous, some are liquid, for example, nicotine, choline, and some of the alkaloids are volatile in nature. The alkaloids are colored compounds which exist in nature. For example, beta-anidine, which will be appears in red, and berberine gives yellow in color. These alkaloids may present as free bases which are soluble in organic solvents and sulfone which are soluble in water, quaternary bases soluble in water, whereas caffeine, even though it exists in free base, it is soluble in water, hence caffeine is said to be as pseudo-alkaloid. As the alkaloids are basic in nature, they are sensitive, hence undergoes decomposition upon storage. These are the major identification tests which is generally used to identify the alkaloidal compounds. Mayer's reagent. Here, the alkaloids are treated with potassium mercuric iodide, which gives cream-colored precipitate. Dragontroff's reagent. The alkaloids, when treated with potassium bismuth iodide, precipitation happens, results in reddish-brown colored precipitate. Wagner's reagent. Alkaloids, when treated with iodine potassium iodide, gives cream-colored precipitate. Hager's reagent. When the alkaloids are treated with picric acid solution, yellow-colored precipitate is formed. Let us see the extraction of alkaloids. The powdered drug initially is refactored and treated with alkaline solution, sodium carbonate. All the alkaloids will be free from bases, which is further extracted with organic solvent like chloroform and ether. It is then concentrated and shaken with inorganic acid. The organic fraction is subjected for removal of solvent, which results in crude alkaloid mixture. Fractional distillation and purification is meant to be done later. The aqueous fraction containing alkaloidal salts extracted with immiscible solvents. Let us see what are the different role aspects of alkaloids. They are reserved substances of nitrogen as they supply nitrogen whenever needed. They act as a defense mechanism in plants. And these alkaloids are end products which are involved in detoxification mechanism. The alkaloids also act as growth regulatory factors of the plant. These alkaloids conjugates with acid and helps in transport of acid. Let us see the very first drug under alkaloids category, vinca. It is commonly called as catharanthus and periwinkle, and the biological source, the medicinal purpose use is dried whole plant of Catharanthus roseus belonging to the family Apocynaceae. And its geographical source, it is widely distributed in Madagascar, India, US and Europe. This vinca is the plant which grows at an altitude of about 500 meters from the sea level, and the propagation was done well in soil type light sandy soil, and the rainfall should be 100 centimeters per annum. The vinca plant is propagated by seed propagation. Generally, the seeds were sown in the month of February. No much irrigation is needed and fertilizers like NPK and farm yard manure is supplied. After 1 year, the stem is made cut at base and the whole aerial part is collected and dried. Whereas the roots were collected after plowing the soil around the roots, and the roots have to be done uprooted. And these roots were washed and shade dried. Let us see about the microscopy of vinca leaf. The upper surface shows rectangular celled epidermis which is covered with cuticle. And you can see the presence of unicellular covering trichomes. The palisade cells are present beneath the epidermis cells. Spongy parenchyma is present with intercellular spaces. At midrib portion, you can see the presence of collenchyma on upper epidermis and at lower epidermis. Xylem and phloem are present at the center. You can see the anisocytic type of stomata in vinca leaf, and the calcium oxalate crystals wraps it. Let us see the chemistry of vincristine and vinblastin. So you can see the presence of indole moiety. So hence it is an indole alkaloid which is derived from amino acid tryptophan. Vinca alkaloids have asymmetric dimeric chemical structure. So whereas two basic multi-ringed units were combined. So one is catharanthus and the other one is vindolin. Both vincristine and vinblastin are identical except for single substitution on the vindolin nucleus, where these two possesses formyl group and methyl group and formyl group respectively. The drug is through inhibition acts as anti-neoplastic agent by inhibiting the mitotic stage at metaphase of the cell by interaction with tubulin protein. The vinca, it is used as anti-neoplastic drug, especially in the cases of myosarcoma, lymphosarcoma, anti-diabetic and hypotensive conditions. It is commercially applied in the formulations as vincristine sulfate and vinblastin sulfate in 10 to 30 microgram per kg and 100 microgram per kg respectively. Let us see the next drug, Rauwolfia, under alkaloids. It is commonly called as Rauwolfia root, Serpentina root, Chota Chand and Sarpagandha. As the root represents the shape of snake, it was commonly called as Sarpagandhamu. The main chief constituents will be present in the roots: Hence, the biosource is dried roots of Rauwolfia serpentina belongs to the family of Apocynaceae. This plant is widely distributed in tropical regions of Asia, America and Africa. This plant grows well in clay-loamy soil with large amount of humus and the soil pH should be 4. The rainfall should be around 250 cm to 500 cm per annum. The Rauwolfia plant can be propagated either by seeds or vegetative. Coming to the seed propagation, the seeds were sown in the month of May. Later, it is transplanted to the main field in the month of August. Chemical fertilizers like urea and ammonium sulfate is produced to propagate this particular plant. And 3 to 4 years have to be completed to complete its propagation. After 3 to 4 years, old plant is preferably selected for uprooting. The uprooting was done by making the soil loose surrounding the root portion and then it is plucked out without damaging the root. The roots were washed and dried. The root color will be, after drying, it becomes grayish yellow to brown. And odorless, taste is bitter. It is subcylindrical in shape, slightly tapering and tetrastitches. Let us see the microscopy of the root. Cork is made up of stratified cells followed by phylloderm containing parenchyma. Parenchyma contains starch grains, few latex cells with resinous matter. Secondary phloem contains calcium oxalate crystals and xylem consists of vessels and tracheids containing simple or bordered pits. Stone cells and phloem fibers were absent. The major alkaloids present in Rauwolfia is reserpine and resinamide. The molecular formula of reserpine is C33H40O9N2 and its melting point is 286 to 288 degrees Celsius. It contains 6 methoxy groups, 1 tertiary nitrogen and 1 NH group. Upon hydrolysis, the reserpic acid, trimethoxybenzoic acid and methanol is formed. Reserpic acid contains yohimbine skeleton, orientation of pentacyclic system. Reserpine is an ester of reserpic acid having a hydroxyl group having trimethoxybenzoic acid. Reserpine carries an axial attachment of indole moiety to the piperidine ring. Rings C and D and T and E are cis-fused. The next chemical constituent is resinamide. Its molecular formula is C35H42N2O9. Its melting point is 460 to 462 degrees Fahrenheit. Upon hydrolysis of reserpic acid, trimethoxycinnamic acid and methanol is formed. Other alkaloids present are agmalacin, yohimbine and cyrosyngopine. Let us see about the chemical test for Rauwolfia. When the fractured surface is treated with concentrated nitric acid, its section results in red-colored medullary rays. And the reserpine, when treated with vanillin in acetic acid, results in violet color, later changes to red color. Rauwolfia, when treated with acid followed by para-dimethyl aminobenzaldehyde, which is known as Banach's reagent. It results in violet to red color. The uses of rauwolfia is antihypertensive, tranquilizer, neuropsychiatric disorders, and it is commercially applied as reserpine in 250 micrograms and resinamide in 500 micrograms. Some of the other allied drugs and substituents are Rauwolfia caphra, Rauwolfia cuminis 5, Rauwolfia obscurea, Rauwolfia rosea, and Rauwolfia bombaceana. The next drug is opium. It is commonly called as raw opium. It is the dried latex which is obtained from unripened capsule of Papaver somniferum. Belongs to the family Papaveraceae. It is widely distributed in India, Pakistan and Afghanistan. Cool weather without freezing temperature and cloudiness and sufficient sunshine is required to propagate this particular plant. And the soil pH should be 7 and it is propagated by seeds. The seeds were sown and after sowing period it will take 3 to 4 months to bear a flower. So when it bears flowers, it matures into capsule which turns dark green to light green. The capsules are incised with nectar at the depth of 2 mm. Latex oozes out and next morning dried latex is scraped with charcoal. Further, it is processed in government factory located in Ghazipur. The odor will be characteristic, taste will be bitter and the color will be dark brown in color. So the chief constituent will be morphine. Opium alkaloids derives from amino acids known as phenylalanine and tyrosine. The alkaloids of benzyl isoquinoline are norcotin, narcine, papaverin, and phenanthrene type are morphine, codeine, and thibine. The chemical formula for morphine is C17H19NO3. The three-dimensional structure has 5 rings. Of these, 3 lies in the same plane. The other nitrogen containing ring and the remaining ring are at the right angles to the other 3. All opioid analgesics have some similarities in their structure, which includes an aromatic ring, a quaternary carbon atom linked to a tertiary amine group by 2 other carbon atoms. Morphine also has a methyl group attached to a nitrogen atom. The other phytoconstituents are codeine, norcotin, and papaverin. Let us see about the chemical test for opium alkaloids. When the opium is treated with water, upon filtration, consider the filtrate and the filtrate have to be treated with ferric chloride, which results in the formation of deep reddish purple color. When the morphine is sprinkled on nitric acid, it produces orange-red color, indicates morphine. If the test doesn't show any color change, it is identified as codeine, as the codeine doesn't respond to nitric acid. If the morphine is treated with potassium ferric cyanide and ferric chloride, it results in bluish green color, whereas codeine doesn't respond to potassium ferric cyanide and ferric chloride. Papaverin, when treated with potassium ferric cyanide, leads to lemon yellow color. Morphine, potent analgesic, sedate respiratory center, hence it produces respiratory depression and constipation. Codeine relieves local irritation in bronchial tract and antitussive, mild analgesic effects. Papaverin shows relaxant effects on smooth muscles on intestine, bronchial tract and blood vessels. Narcotin is a specific depressant action, and its commercial application as morphine sulfate in the dose of 10 mg, codeine sulfate 10 to 20 mg, narcotin 15 mg, papaverin hydrochloride 150 mg. And the allied drugs and substituents are papaverin dubium, papaverin orientate, papaverin intermedia, and papaverin artimone. The next drug is atropa. It is commonly called as belladonna leaf, and it is also known as deadly nightshade leaf. The chemical constituents present in leaves, hence the biosource is dried leaves of Atropa belladonna, belongs to the family Solanaceae. It is widely grown in England and European countries. It grows well in 1400 meters above from sea level, and it is propagated by seeds. The seeds were sown in May. During its propagation, urea, potash, and superphosphate is used as fertilizers. After plant reaches maturity, their leaves and flowering tops were collected, dried, and stored. The color will be green to brownish green, odor is slight and characteristic, and the taste will be bitter. The shape of the leaves are ovate, acuminate apex, petiolate, and it contains entire margin. If you see the section cutting of Atropa leaf, the epidermis is striated cuticle and it contains anisocytic stomata. Uniseriate multicellular covering trichomes are present, and you can also see the presence of glandular trichomes containing uniseriate with unicellular head. Mesophyll with single layer of palisade and spongy parenchyma containing microspinoidal calcium oxalate crystals were observed. If you see the chemical constituents of atropine, it consists of hyoscyamin, which is a racemic mixture of atropine. The other constituents are belladonnin, scopolamine, and hyoscine. Atropine, its molecular formula is C17H23NO3. Its melting point is 114 to 116 degrees Celsius. It consists of tropin and tropic acid moiety. It is the racemic mixture of L-hyoscyamin and D-hyoscyamin. The tropin moiety is synthesized from amino acids ornithine, and tropic acid is synthesized from phenylalanine. Fusion of pyrrolidine and piperidine ring with common methylated nitrogen is observed. The other compounds are hyoscine. Let us see about the chemical test. All the tropane alkaloids are response to the specific test known as Vitali-Morin test, and also for Van Erck's reagent where we discussed during the drug Pinka. In Vitali-Morin test, the powdered drug is treated with nitric acid solution and evaporated to dryness. Further, the methanolic potassium hydroxide, which is prepared with acetone solution, then acetone solution is added, results in the formation of purple color. The uses of atropine is it is parasympatholytic drug with anticholinergic properties, and it reduces secretions like saliva, sweet, gastric juice, reduces secretions like saliva, sweat, gastric juices, and it is strong purgative, acts as an antidote for opium and chloral hydrate poisoning. It is commercially applied as belladonna tincture in 0.6 to 1 ml. Their allied drugs are Phytoleca americana, Solanum nigrum, and Ailanthus glandulosa. So these are the few examples under alkaloids. So coming to the alkaloids occurrence and their medicinal importance. Phytomedically, most of the alkaloids are used for medicinal purposes, widely used for medicinal purpose. In this particular, these alkaloids were also categorized based upon according to whether some of the compounds will fit to the definition generally, and the same alkaloids were classified even on the chemistry basis based upon the basic moiety present in the chemical constituents. Later, the identification tests. So, four different reagents were used to identify these alkaloids. Under alkaloids, vinca is the drug which acts as anti-neoplastic drug, and it is widely using from ancient times to until its identification from times to now. Likewise, rauwolfia acts as an antihypertensive drug, whereas the anticholinergic properties were associated with atropine. So the important phytochemical compounds were discussed in regard of alkaloids under Unit 2 regarding the first part. After completion of this Unit 2, I will be providing the additional notes information along with the references and web links. After this, you have to submit the Google form which contains 5 to 10 questions where the mark grading will be given so that the subject knowledge can be assessed. Thank you for your patience, listening. Thank you. We'll meet in the next session.